What's up, what's up, what's up? It's Gradius coming at you live from Dipoli. And here's your video for Rational Exponents Part 2. So let's get it. Now, first thing I want to do is just do a quick little recap of changing the exponent with a fraction in it into square root or cube root or quad root or fifth root, anything like that. Change any of our roots back to an exponent form. So if I have 7 to the 5 6 and I want to change it to a square root or any kind of root, then what I need to do is I would follow these steps. So I know I'm going to have the 6th root because my denominator is a 6, and then my radical would be 7 to the 5th power because my numerator is 5 and my base is 7. Same thing here, going backwards now. My base would stay the same, so this would be 37. The exponent under the radical would be my numerator, and then the root on the outside would be my denominator. So that was just a quick recap of that. But what I really want to get into is solving equations. Okay, so yesterday we did, the previous video, part 1, we were talking about product of powers in solving equations. Okay, I feel like that one's kind of the most basic. Not that these are any more difficult, it's just now we can use different properties in order to solve these equations. And so let's see what we can do here. So we're going to do power of powers here, and I'm going to talk about why we're going to use a different property for these ones. So now if we look, I have 27 to the power of x minus 4 is equal to 3 to the power of 2x minus 6. So notice how I have different bases here. Now we know with all of our properties we have to have the same base in order for them to work. Okay, so I don't have the same base right now, which is a problem. And so what I need to do is I need to figure out how can I have the same base. So am I able to go backwards with one of these numbers? Am I able to change this 27 into a base of 3, but with an exponent? Okay, so what I mean by that is 27 can be broken down into exponential form as 3 to the 3rd power, because 3 to the 3rd is 27. So 3 to the 3rd and 27 are equal to each other. So I'm just going to change 27 to 3 to the 3rd power because if we notice, now I have the same base. But that is still all being raised to the power of x minus 4. So if we look here, I have 27, I just changed it to 3 to the 3rd power, but that is still, if I put this in parentheses, that is still being raised to the power of x minus 4. So I still have it being raised to the power of x minus 4, but now I have the same base here, so now I'm like, okay, so now we can actually make things work. I can make the left side equal to the right side because we have the same base and we have some exponents, and that's fine. Now what I can do is I can use my product of powers property because we just used it right now to show that we know 27 is 3 to the 3rd, but now if we look, I have x, because it's product of powers here, because it's power of powers, I just said product of powers a couple times. Because I have a power raised to another power, what I can do is we know by the power of powers rule, or our property, is that when we have a power raised to another power, is we multiply this piece by this piece. Okay, so I need to do 3 times x minus 4. So when I do 3 times x minus 4, it's like the distributive property, right? So this is 3x and then 3 times negative 4. So I have my same base, and this becomes to the power of 3x minus 12. I'm just multiplying my two powers because that's what we do when we have a power raised to another power. And that's going to be equal to the base of 3 raised to the power of 2x minus 6. Now hopefully here you can see what we need to do next. We have the same base, we just have one value for an exponent up here. So now all we have to do is we have our new equation, is I need this to be equal. We know that these two values have to be equal to each other for the left side and the right side to be equal to each other. So my equation that I can solve is 3x minus 12 equals 2x minus 6. Now, that's a minus 12, and I changed my, whoops, sorry guys, give me a second here. So 3x minus 12 is equal to 2x minus 6. So now I can just solve real quick. This should be a pretty basic equation. We have x minus 12 equals negative 6. Add 12 to both sides, and I get x equals positive 6. So if I were to take x, plug it in for positive 6 in both of my x values here and here, I should have the left side and the right side be equal to each other. 6 minus 4, that would give me 27 squared. This would be 12 minus 6, that would be 3 to the 6th power. And those should be equivalent to each other if I checked them in a calculator real quick. Okay? And that's it. So let's just look at another one here. You can try it on your own if you'd like, or you can just pay attention here. That's fine. So this one looks a little bit different because we have fractions as our base, and that's fine. That doesn't change anything because what we look at here is I see 25 and I see 125. Now, I'm really just looking at my denominators right now because I know that these are going to end up being a negative exponent because we have that 1 in the numerator. Okay, so I'm really just looking at 25 and 125 and figure out how can I break those down so that they have the same base. Okay, I can't do 25 squared, or break down 125 to 25, because 25 squared is definitely not 125. But I know that if I have a base of 5, I think I can get to 125 and 25, because I know that 1 over 25 is also 1 over 5 squared. So I know 25 is the same thing as 5 squared. I also know that 1 over 125 is the same thing as 1 over 5 to the 3rd power. So it looks like I'm going to have a base of 5. Okay. Now, if I get rid of this, I want to get rid of this 1 over nonsense. So this is the one time we actually want to make our exponents negative. So we're going to go backwards, and I know this is 5 to the negative 3rd power. Okay, so what I did is 5 to the negative 3rd power is equal to 1 over 125. We just kind of broke it down backwards. And all of that is still being raised to the power of negative x over 2. And now I'm going to set that equal to 5 to the negative power of 2, because that's going backwards, right? Making that a negative exponent. All raised to the power of negative x over 3 minus 2. I have my same base, which is good, but I do need to do my power of a power property here and actually multiply. Okay, so let me multiply over here on the side, and then we'll erase and kind of keep going. So when I do my negative 3 times negative x over 2, think of it like this. This is just 3 over 1, x over 2. Negative 3 times negative x is positive 3x. So that becomes 3x over 2. Okay, so I'm going to erase this if we're okay with that, so I can start working above. We'll change the color here. So this, I just multiplied these two values. So this became 5 to the power of 3x over 2. Now I have to multiply my negative 2 over here. So really I have negative 2 times negative x over 3 minus 2. It's a distributive property. This is going to give me positive 2x over 3. Negative 2 times negative 2 is positive 4. So this is equal to 2x 5 raised to the power of 2x over 3 plus 4. Okay? Now I know this has to be equal to this because we have the same base. So now we can actually solve. Okay? So I'm just going to give it some space. And let's solve. I have 3x over 2 equals 2x over 3 plus 4. So we want to get our variable to the same side. So I'm just going to subtract this whole term, 2x over 3, from both sides. Okay. Now I don't have a common denominator yet. That's fine. I'm going to make a common denominator after I get it all set up so it looks like the equations that we've been solving already. So I have 3x over 2 minus 2x over 3 equals 4. Now I can solve and get my common denominator. So if I multiply this whole bad boy by 3 over 3, and then I can multiply this whole equation by 2 over 2, and that'll give my common denominator. So it's really 9x over 6 minus 4x over 6 equals 4. That's going to give me 5x over 6 equals 4, which means I can multiply by 6 over 5. Multiply by 6 over 5. And that's going to give me 24 fifths. And I'm done. A lot of work for this problem. This one was a lot of steps. But if we just take it one step at a time, it should be pretty simple just in regards to the fact that we know we have to break down this to get the same base. And then from there, we just got to set the side, make sure we get the sides set equal to each other and solve an equation. So x equals 24 over 5. Definitely want you to try this one on your own, please. Try this one on your own, because then I want to show you quotient of powers, and then we'll be done. So pause, try it on your own. Okay, so for this one, the big thing here is trying to figure out how we break it down. Do I need to have a base of 4? Can I get 4 to 256? Or do I even need to break 4 down to 2? And can I get 2 down to 256? So we have to know, this might take a little bit of guessing and checking. This is where a calculator comes in handy, okay? Because if I check, I know 4 times 4 is 16, times 4 is 64, times 4 is 256. So 4 to the 4th power is 256. So that worked out nicely. I can break down 256 to 4 to the 4th power. And then I still have this also being raised to the power of x plus 2, and this is all equal to 4 to the 3x plus 9. Okay? Now I have to do my power of a power property, so I have to multiply these. So this is really 4 times 4x plus 8. I just did distributive property, essentially. I multiplied 4 by x plus 2. And that's going to be equal to 4 raised to the power of 3x plus 9. Okay? Now that I have the base and I have my exponents, I can set my exponents equal to each other. 4x plus 8 equals 3x plus 9. And now I can solve for x. Subtract 3x from both sides. X plus 8 equals 9. Subtract 8 from both sides, and x equals 1. And I'm done. Okay? So that's all we have for power of powers. One more problem I just want you to see. This is our last problem, okay, where I'm only going to show you one for quotient, because I think you guys could actually try it on your own and figure it out. Because now it's very similar to product of powers, but now we're just using quotient. Okay, so we're just using our properties. We have division, and so we have to figure out, we know with division we have to subtract our exponent. So try to set it up on your own. See if you can do it before I do it, and then I'll show you how to solve this one. Okay. Why does algebra make you a better dancer? It's because you can use algorithm. Whew. It's probably my favorite one yet, guys. Okay, so 2 to the power of x raised to the power of 1/3. And then I have the same base here. I have the same base on top, same base on the bottom. What I know about quotient of powers, if I had like 3 to the 5th over 3 squared, we know that that's the same thing. That's 3 to the 5 minus 2. It's just 3 to the 3rd. We just subtract the exponents. So we're going to do the same thing here. But first, I want to get rid of this power of a power first. So I need to multiply x by 1/3, which is going to give me 2 to the x over 3 all over 2 to the 1/3, and that's equal to 2. So because this is x over 3 over 1/3, this is really, I'm just subtracting these like what we did here. We just did 5 minus 2, so I need to do x over 3 minus 1/3. I'm going to go this way. So that's 2 to the x over 3 minus 1/3 is equal to 2. Well, there's no exponent here, but we know if there's no exponent, then we can put the power of 1 up there, because 2 to the power of 1 is just 2. So really, there's my equation set up. X over 3 minus 1/3 equals 1. Okay? That's what I'm trying to find here. So I'm going to do that right here in the space above. X over 3 minus 1/3 equals 1. Luckily, they already have a common denominator, so I just subtract the numerators. So that's just going to become x minus 1 over 3 equals 1. I just did x minus 1. I can't actually do x minus 1, but I can set it up as one fraction since they have a common denominator. Okay? And then now I get to multiply both sides by 3. So that's going to give me, that's going to cancel. X minus 1 equals 3. Add 1 to both sides, and I get x equals 4. I'm done. And that's it. Okay, so I hope this helped. Hopefully we have a better understanding for how to solve these equations using our properties. If you have any questions, please do not hesitate to ask. And thanks for watching, guys. G out.